Okay, now we want to develop the idea of a matrix product. First thing we need to know is what's a matrix. Well, here's an example of a matrix. A matrix could be written with a row 1, 3, negative 5 and another row 2, negative 1, 4. So this matrix has rows, 2 rows, 1, 3, negative 5 and 2, 1, 4. Okay, well I'm going to circle the first row in colors, and I'm going to circle the second row in another color. This matrix can thus be written as row 1, row 2, where row 1 is this, row 2 is this. So that this is R1 and this is R2. That should be pretty clear. If I write a matrix consisting of this row and this row, it's going to look like this. And it can be represented as R1, R2. Alternatively, it could be written in terms of columns. So if these columns are, and I'm not going to color code them, but I'm going to call this column C1, this one C2, this one C3. Then I can write this thing as, and of course the columns, why are the columns 1, 2, 3, negative 1, 5, 4? Because first column is 1, 2, there's the first column. Second column is 3, negative 1, there it is. Third column is negative 5, 4, there it is. And it should be negative 5, 4. Again, you have to watch me for stuff like that. Okay. Now, with that notation, I can write this as column 1, column 2, column 3. We understand columns go down. So there it is. There's the row representation of the matrix. Here's the column representation. Now, if I want to do a matrix product, for example, if I want to do the product of this matrix, 1, 3, negative 5, 2, negative 1, 4, with, say, the matrix 2, negative 1, 3, 5, 1, negative 6, I can't do it. Okay? Not going to work. Why not? Well, because when we multiply matrices, we multiply a row of each matrix by a column. We multiply rows of the first matrix by columns of the second matrix. So this multiplication isn't going to work because this row has length 3 and the columns here have length 2. Okay, so that's not defined. So I'm going to change that a little bit. Okay, I'm going to come over here and say, okay, well, let's see. What can I do about this? If I want to demonstrate a multiplication, all I've demonstrated so far is that if your rows and columns don't match up, you can't do the multiplication. Okay. Now my second matrix has columns of length 3. My first matrix has rows of length 3. So now I can multiply them. And how do I do this? Well, seems that I can't count, but let's write the first matrix as row 1, row 2. Let's write the second matrix as column 1. Now I don't want to use the same notation I used here because we might confuse C1, C2, and C3 with the columns of the first matrix, and I want them to represent the columns of the second matrix. So I'm going to put a little hat on my column to show that this is a column of the second matrix. Okay? So, when I multiply the matrices, I'm going to multiply row 1 by column 1, and I'm going to multiply row 2 by column, or row 1 by column 2. In other words, each row will multiply both columns one at a time. Then I'll multiply row 2 by column 1 and row 2 by column 2. And I'm going to put the results in the row and column they came from. That is, when I multiply row 1 by column 1, I'm going to say that's row 1 times column 1 of the second matrix. Okay? And this goes in the first row and the first column of the product matrix. If I multiply row 1 by column 2, I want to put it in row 1 of the second matrix, the product matrix, and column 2. So row 1, column 2 goes here. Then I multiply row 2 by column 1 and row 2 by column 2. When I do row 2 times column 1, it's going to go in the second row and first column. So here I have second row, first column. And row 2 times column 2 similarly goes over here. Now just digress for a second. Why am I using these funny looking C's? Because I don't want to mistake them with lowercase c's that we use a lot. So we want to be careful to distinguish these. These funny looking C's stand for columns. The funny looking C's with the hats on them stand for columns of the second matrix when we're multiplying two matrices. Okay, well, we can then do the rows times the column. Okay, if I take the first row by the first column, I have 1 times 2, 3 times 5, negative 5 times 1. I don't want to write all that out just because we don't want to make the video too long, so I'm going to do the arithmetic, but you check me on this. 1 times 2 is 2, I'll bet you I got that right. 3 times 5 is 15, so we're adding these, so we have 2 from here and 15 from here, so our total is 17 so far. And then negative 5 times 1 is negative 5, and 17 minus 5 is 12. Now I'll write out the numbers. So when I do my row 1, column 1, my row 1, column 1, it's going to go here. Now I'm going to do the arithmetic in another step. I didn't want to go to the extent of writing 1 times 2 and 3 times 5 and negative 5 times 1, so I kind of skipped that step. Okay, then we're going to multiply row 1 by column 2. And we're going to have 1 times negative 1, that's negative 1. 3 times 1, which is 3, add that to the negative 1, we have 2. And negative 5 times negative 4 is 20. So I believe we get negative 1 plus 3 plus 20. And that's going to add up to 22, just like this is going to add up to 12. Okay, same thing here. Second row times first column, going to go in the second row and first column, second row, first column. 2 times negative 1 is negative 2. And I'm just going to write that now. That's negative 2. And negative 1 times 1 is minus 1, and 4 times negative 4 is minus 16. And then finally, second row times second column. 2 times negative 1 is negative 2. Negative 1 times 1 is negative 2. Negative 1, uh-oh. And 4 times negative 4 is minus 16. And you know what I did? My eye caught the second row here, so when I did this, I wrote the result of the second row by the second column, which does not go here. It goes here, because it's in the second row, certainly, but also the second column. Still better do the second row times the first column. And that gives us 2 times 2, which is 4, negative 1 times 5, which is minus 5, and 4 times 1, which is 4. Okay, now that I've written it out, hopefully correctly, and you can correct my arithmetic if I'm wrong, we get okay, we got another one to correct here. 1 times 2 is 2. We have 2 and 15 and negative 5, which I already did. It adds up to 12. When I got to writing out the numbers, I got careless. Okay, so we get 12. 2 and 20 is 22. 4 and 4 is 8, minus 5 is 3. Negative 2, negative 1, negative 16 is negative 19. And here's our product. Now, in general, if we have, and let's make sure I've got enough room to write this out. I don't want to go lower than this on the board. And how low can I go over here? Yeah, about the same. Okay, hopefully it won't get too cramped. If I have row 1 through row M, okay, row 1 through row M. This stands for row 1, then row 2, row 3, row 4, all the way up to row M, whatever M has to be. And this could be a huge matrix. Matrices that are used in current artificial intelligence, you know, could be 1,000,000 by 1,000,000,000. Yeah, probably not that big, but by the time you see this, they might be. Okay, so we have row 1 through row M multiplied by column 1. I'll use column 1 hat, so we know that this is column 1 of the second matrix. Through column N hat, where M is the number of rows and N is the number of columns. For this matrix, M would be 2, you have 2 rows. N would be 3, you have 3 columns. For this matrix, M, the number of rows is 1, 2, 3, and the number of columns is 2. Now there's terminology that you can see. You call this then a 2 by 3 matrix. You call this a 3 by 2 matrix. In any case, when you do this, your result is row 1 times column 1 hat all the way up to row 1 times column N hat. And it comes down here to row M, and let's make sure I can see that M. Let's adjust the camera just a little bit, excuse me. Okay. So row M times column 1 hat up through row M times column N hat. Now these dots indicate that there's a whole lot of stuff in between here if these are large matrices. If you're doing a product of, let's say, a relatively modest matrix with, say, 12 rows multiplied by a matrix with 15 columns, then for every row you're going to have 15 products. You're going to have row 1 column 1 through row 1 column 15. So you have 15 entries in this row, and then you have, what did I say, 12 rows. So you're going to have 15, and then 15, 15, 15, all the way down here to where you have 12 rows, each with 15 numbers. There's 180 numbers in this matrix. Now that's, again, a relatively small matrix, but probably bigger than you really want to do by hand. Now what we do in this course is, the first thing, we deal with relatively small matrices, usually no more than 3 rows, no more than 3 columns. We establish a lot of what we want to talk about, and then we generalize things to larger numbers of rows and columns. In any case, here's the definition of the matrix product. And this is the definition, the working definition we're going to use in this course. There are other ways to write this out, and I'll probably do a brief video still using this board, but I'll write out the way the product would be written in terms of summation notation. I don't want to confuse the issue at this point. I hope the process is clear, very simple. You just got to get used to it. You do a few of them and you have the idea.